Lovely candidates, welcome back to the channel. Previously, we were looking at the properties of magnetism. We recited the properties of magnetism. We did some experiments on about 5 properties, and we even went into the illustrations. Right now, we are going to look at magnetization. Don't forget to subscribe to the channel, like the videos that are there. In case you've missed any videos, please, they are all uploaded. Make sure you get them, download them, watch them during your free time. Right now we are going to look at magnetization. Magnetization is the process of making magnets. Magnetization is the process of making magnets. We have a second definition. It is the process of making a magnetic material gain magnetism. That means when we are making magnets, we have to use materials that are magnetic. Don't use aluminium, don't use copper, don't use those materials that are not magnetic, because we said they cannot form a good magnet. Use materials like iron, especially if you have soft iron. Some magnetic materials are easier to magnetize than others. So, it is the process of making a magnetic material gain magnetism. You remember the definition of magnetism. Magnetism is the force that enables a magnet to attract other magnetic materials. We are going to look at 3 methods. We're going to look at 3 methods. Basically, these 3 methods are going to be practical. Then in part 2, we shall go through the theoretical bit. Majorly, this segment is going to be very practical. We're going to carry out experiments together. There are 3 methods of magnetization. The methods we are going to look at are 3. Some people would call them 4, but I see there are 3. These 2, I consider these 2 to be 1. These 2, I consider these 2 to be the same method. So we are going to look at 3 methods of making temporary magnets, or 3 methods of magnetization. The first one will be induction method. The second one will be stroking method. Stroking method is done in 2 ways. There's single touch method and there's the double touch methods. Some books take each of these to be separate methods of magnetization, but in this case, let's take it that there are 2 ways of stroking. Then the third method will be the electrical method. Electrical method. So induction, stroking, and electrical method. We are going to begin with induction method. Induction method, we need to look at the definition. We shall look at the diagram in a later segment. We shall look at the poles, the polarity, and the factors responsible for the strength of this magnet. So right now, we are going to do the practical together. So with the induction method, this is my apparatus that I'm going to use. With the induction method, what we do is we use a permanent magnet. This is a permanent magnet. And the permanent magnet, the magnetic material is brought closer to the permanent magnet. So this magnet has attracted the nail. But now, this nail, since this nail is within the magnetic field of the permanent magnet, it has also become magnetized. It has become magnetized by induction. Therefore, it's a temporary magnet, meaning it can easily lose its magnetism. It can easily become demagnetized. What shows that it is a magnet right now? If I attach another magnetic material, there is attraction. There is attraction, meaning this is now a magnet, but it's a temporary magnet. Even this one is a magnet. What shows that it's a magnet? Let's check this out. Let's see whether it can attract the staple wire. It has picked up the staple wire. So There's the permanent magnet and the rest are temporary magnets. And don't forget that we said one property of magnets is magnets have a north pole and a south pole. So each one of these has a north pole and a south pole since they are now magnets. And what do you think is going to happen when I detach the upper permanent magnet? The temporary magnets become demagnetized. They have lost their magnetism because they are out of the magnetic field of the permanent magnet. So, definition. This is a method of magnetization where a magnetic material is made into a magnet by bringing it close to a permanent magnet, by putting it into contact with the permanent magnet. The diagram we shall see in the theoretical segment. The poles we shall also see in the other segment. The poles. Factors responsible for the strength of this magnet. There are around 2 or 3 factors responsible for the strength of this magnet we have made by induction. Number 1, the strength of the permanent magnet. The strength of this permanent magnet determines the strength of all the other new temporary magnets. If we have a very strong one, you will find a chain of new temporary magnets. But if this one is weak, then our new magnets will be weak. Then 2, the closeness to the permanent magnet. Their closeness. If we have the first nail is our first temporary magnet, then the second nail is our second temporary magnet. We even have a staple wire. So the first nail automatically is stronger than the second nail because it is closer to the permanent magnet. So those are the factors that are responsible for the strength of this magnet, the temporary magnets. Then moving to the second method, which is called stroking. Stroking, the infinitive of this verb is stroke. It comes from the word stroke. To stroke means to pass over. Passing something over the other is stroking. I hope many of you have ever stroked your cats at home. So we are going to magnetize. I have these 6-inch nails. We are going to magnetize them by stroking. Let's first check this out. Before stroking, the nail cannot attract the staple wires. Bring the camera closer. It cannot attract the staple wires before I stroke. Right now I'm going to start stroking. I'm stroking, I'm passing it over. That is how stroking is done. You make sure that the permanent magnet goes over the magnetic material. And you make sure that you pass it far above so that the magnetic field does not interfere with the new magnet you are forming. After a number of strokes, we need to know whether our new 6-inch nail can attract the staple wires. Look at that. I hope you can see that. We have a new temporary magnet which is attracting the staple wires. That method is called stroking. Going back to our menu, the ways of stroking. I've used a single magnet. I have used a single magnet, therefore it's called single touch. If you use 2 magnets, when you use 2 magnets and the 2 magnets are stroked, one moving clockwise and the other one moving anti-clockwise, as you stroke them over the magnet with the opposite poles, that will be double touch method. The diagrams of stroking, we are going to see them in the segment for theory. Factors responsible for the strength of this magnet that we have made by stroking. Factor number 1, the number of permanent magnets you're using. All factors constant, we would expect double touch to produce a stronger temporary magnet than single touch. If we are using the magnets of the same strength and you're using the same strokes, then two number of strokes. If I give two students to stroke a magnet, one makes 10 strokes, the other makes 50 strokes. Holding all other factors constant, we would expect the one with 50 strokes to make a stronger magnet than the one with 10 strokes. The polarity of this magnet, polarity has to do with the poles. How do we identify the poles of our new magnet that we have formed? By stroking. We shall see that one in the theoretical segment. Let's finally move to the electrical method. Electrical method definition. It is the method of magnetization where current is passed through, where a magnetic material gains magnetism by running current through a coiled wire. The coiled wire is coiled around the magnetic material, and then electric current is run through that coiled wire. Then the magnetic material within will become a temporary magnet, and that temporary magnet has got a special name. It's called an electromagnet. Electromagnet, one word. The new magnet we shall get is called an electromagnet. Electromagnet. Diagram we shall see in the theoretical segment. Let's first perform this. Bring the camera closer. Now I have used, this is a 6-inch nail, and it's, of course, it's magnetic. We have to use magnetic material. Before running current through it, before running electric current through it, it cannot attract the staple wires. We are using staple wires because they are really very light and they respond to magnetism. We have got dry cells here. This is going to be our source of electricity. We are going to run current. I'm going to run current through this coiled wire. The coiled wire is insulated. It does not have to get into contact with the nail, because we shall have a short circuit, we shall not get what we want. So it has to be well insulated. I've put masking tape because it was so flexible that it was unwinding. It was failing to stick onto the what. So right now, let me run current through it. We have already done these practicals a number of times. Yes. So let's see whether our nail has become magnetized. Can you see that? Let me release. Oh. So it has become magnetized. So let's check this. It is still retaining some magnetism, but of course it's a temporary magnet. Very soon it will not be attracting anything. Let's run it. Let's run current through once again and see whether it can really lift that heavy nail. Check that out. When I release, it becomes demagnetized. Let's see whether we can lift like 3 nails. Then we are trying. Look at that. So what happens when I open the circuit? What happens when I open the switch? The other nail, this nail here will become demagnetized. There we go. So this is an electromagnet. It is an electromagnet which is magnetized by electrical method, and it's called an electromagnet. The coiled wire that you're seeing here is called a solenoid. Now we need to go into the factors responsible for the strength of this magnet. Factors responsible for the strength of this magnet. Number one, the voltage. The number of dry cells we are using are responsible for the voltage. Also, you would say number of dry cells or voltage. Two, the number of coils on the solenoid. The number of coils on the solenoid are also responsible for the strength of this magnet. Advantages of these electromagnets is that they can be magnetized and demagnetized at will. They are magnetized or demagnetized at will. Examples of devices that use electromagnets, we have the electric bell. So the question can come, identify ways in which the electromagnet is used in your school. You just say it is used in the electric bell. They are also used in loudspeakers. Loudspeakers have both permanent magnets and the electromagnet. Then electric motors also have got coiled wire, also have got an electromagnet. So that is the way in which it is applied. Electromagnets are also used, they are also used at the junkyard to lift scrap. They are used in steel industries to lift scrap. So the advantage is they can be magnetized and demagnetized at will. So when you go at the junkyard, you will find that there are those big, large electromagnets, and they are put on cranes and on some vehicles, and they're used for lifting scrap. You can find them lifting a matatu or taxi, something as heavy as a taxi, provided it is magnetic. So we have done the three practicals. The first one was induction method, where we brought the magnet close to the magnetic material, and the magnetic material became demagnetized. Stroking means passing something over the other. So we passed permanent magnets over a magnetic material, and it became magnetized. Then three, the last one I've just done now, is called the electrical method. Electrical method, that one we have to use current. So we normally have questions like, identify the method of magnetization where electricity is used. That's the electrical method. Identify the method where permanent magnets are used. It is induction or stroking method. But again, even when you write any of these, still you will get your mark. Identify one method of magnetization, or one method of making temporary magnets where permanent magnets are not used. You should be able to twist things the way the examiner wants. I thank you again for watching. The next segment will be for the theory of this whole thing. We need to see the illustrations, the diagrams of the three methods. We need to identify the poles. Which ones are the North Pole on our new formed magnets, and which ones are the South Poles, and so on and so forth. I thank you for watching the whole of this video. Keep watching it again and again. Subscribe to the channel and stay safe from Corona. Thank you for watching.